Hello everybody. Here I have another Tempest main board. Anyway, this is a new main board and a previously repaired auxiliary board. But this is a different main board with another ROM hack. And I've got this guy all hooked up here. I've got my voltage tester ready to go. I got my logic probe ready to go. Actually, I need to hook this to ground. Here's a ground. Okay, so we're ready to go with this. I'm just going to put it right on the 5-volt DAC. That's the first thing we'll check. I'm going to turn this on. Wait for it to light up, because I want to see what happens as soon as I plug this in. Okay, there we go. There's our dot. So let's plug this in and kind of watch the screen here. Okay, it is plugged in and we got a dot. That's it. So the spot killer would be on. I'm going to turn this off. The spot killer would be on. This thing isn't doing anything. And we got 4.93 volts for the DAC. That's fine. Let's switch over to, this is one of the 15s. That's 15.3 negative. Here's positive. Positive 15, good. Here is the 8 point or 6.8 or whatever. That looks good. And our main 5 is 493, which is fine. So voltages are all good. Unhook. Let me take the logic probe since we're not doing anything. Let's check our clocks. Okay, here's reset. We're resetting. Here's the CPU clock. That's good. Not sure what that's supposed to be. Power reset. I think these are data lines. Data lines going down to address lines. Everything's moving. Let's check our control signals. 1, 2, 3, 4. This is interrupt. And interrupt is active low, so this thing is constantly an interrupt. And this is non-maskable interrupt, which this might be held high. I don't know. I'll have to look at the schematic. And here's all of our addresses. So that's all doing something. But main concern right now is the interrupt is low all the time. And that can't be low all the time, because the CPU is going to want to start doing something. Okay, I want to go to the reset vector. I want to start running code and everything, and the interrupt saying, hold on, no, don't do anything. Don't do anything. Constantly being interrupted. So that's the first thing to fix, is the interrupt. So we'll have to look at the CPU, the microprocessor section of the schematic, and find out what is going on with the interrupt. So let's do that. Let's put the schematic on the TV and check it out. Okay, here is our IRQ counter, interrupt request counter. It's a 161 at E4, and you can see it's being cleared by reset. So it should never be cleared if it's running properly. It loads a value of E4, so it counts 11 times and sends a ripple out. Reloads 4, counts 11 times, sends a ripple out, over and over and over. Carry out, sends a carry out. And then it goes through an inverter and then clocks to 74. Okay, the 74 data is tied low, so the watchdog clear needs to be continuously pulsing to keep this a 1. So it's basically going to be a timing thing to where this is always keeping this set to 1 when it's running. So, yeah. So this is what we have to, these 3 chips we need to look at. So let's do that. Let's start with the counter. Let's start with E4. So I've got it turned on. I just turned it on. We'll find E4, which is this guy, E4. I know the clock is 2. There's our clock. Okay. I disabled the watchdog, by the way. Okay, these are our counts. And here's our carry out. So that seems to be doing what it needs to be doing. Here is, this I think is the 04. The 04 is, yep, E3 pins 13 out to 12. So 13 out to 12. That's good. Next we go to D3, which is this LS74, which is clocked on 3 with data being held low. And our output is on 5. 3, 4, 5. And 5 is always low. So we need to check pin 4 is watchdog clear. And there is the problem. Watchdog clear is not present. The watchdog clear signal is not present at this chip. So it's never going to set to 1. So, well, we're going to have to look at the schematic and find out where watchdog clear comes from. So let's do that. Let's dig around the MPU part of the schematic and find watchdog clear. I misspoke. This is not going to be always held high. This is going to pulse low to set it to 1 every so often. And this will always be trying to clock it back low. So this will set it to 1, this will clock it low. It'll be between these 2 signals that output this signal. That'll set it to 1, that'll set it to 0. And it'll just be, yeah, I said that that'll always hold it high. That's not true. That was wrong. So just misspoke and wanted to clear that up. Okay, and this is where we want to be at the address decoder. Here's our watchdog clear signal right there. And it's off of this 139 at J5. It's the 139 Y2 is watchdog clear, which is binary 2, the binary 2 output 0, 1, 2, 3. So that means when B is 1 and A is 0, and this enable has to be enabled. So when enable's low and B is 1 and A is 0, that will go low. So I think where we're going to start is we're going to start right here at this 139, and we're just going to probe these signals. We're going to make sure it's being enabled. It has to be pulsing. And then we're going to make sure that these two guys are pulsing. And if all of that's happening, then I'm going to assume that this is bad. But we'll have to hook up to it to verify, because it may be something else. I mean, we want to look at it and verify that it's not working correctly. We just don't want to assume, I guess. So this is where we'll start. We'll probe these, make sure these are pulsing, and if they are, well, then we should be getting pulsing over here. And if we're getting like one line is pulsing, or maybe two of them or whatever, then we're going to want to hook up to this and actually analyze it and look at it and make sure, is it working correctly or is it not? So that's what we'll do first, is this 139. Probe around, check it out. Okay, we are going to look at J5. That's that 139. So let's go ahead and plug in. And the 139, its pins 13 and 14 are the select lines, and 15 is enable. So here's 13. Okay, that's pulsing. That's good. 14 is also pulsing. And here's the enable. Oh boy, which enable is always high. This is not ever being enabled, so it's never going to send anything out. No enable on the 139. Okay, well, let's unplug. Unplug the 139. Gets its enable off of the LS32. Okay, so we've got a 139 over here with unbuffered address inputs. Pretty sure that's okay. So we'll have to check this 139, check for pulsing here on pin 6. I want to make sure it's pulsing. I guess just start right here. Let's start at C3, pin 8. Let's look at 9 and 10 out to 8 on this LS32. 9 and 10 out on 8. So let's look at that. Okay, we're going to look at C3, which is this guy, LS32. C3. And we're going to look at 9 and 10 out to 8. Here's 9. 9 is always high. Let's look at 10. 10 pulses. Okay. And let's look at 8. Always high. It's an OR, so that or that. This line always being high. It can't always be high. It's an LS32. This one's pulsing. That one's not. So pin 9 is what we got to look at. So let's go back to the schematic. Pin 9. Pin 9 is this 139 here at B3. So what we need to do is look at pins 1, 2, and 3. If they are all moving, which I suspect they will be, then let's probe these. And it looks like these all should be doing something. They're all signals. Video memory here. So let's, I'm particularly interested in 6. So let's do that. B3, 1, 2, 3, and 6. B3 is this mess. B3, okay. One. Here's one. Jesus Christ. That's pulsing. 2, 3, 4, 5, 6 is not pulsing. I'm going to remove this nonsense. You know what I'm going to do? First things first. I'm removing this, and I'm going to burn ROMs for this board. I don't like this ugly hack, ugly messy hack. Taking care of that first and foremost. Okay, I will be back. I'm gonna remove all this. I'm gonna set my programmer up. I'm gonna burn some ROMs. Okay, much better. Now, I don't know everything about Tempest hardware, but I know that this revision of this board, you can run 2732s, half as many EEPROMs with these jumpers. These jumpers are not on every board. Like, they're not on the one I just repaired does not have this little section right here with these jumpers. So I just moved the jumpers over to here per the schematic, and I can now use 2732s. So that's what I did. I was running a little low on 2716s, so I went ahead and restrapped it for 2732 EEPROMs. Yeah, so these are actually basically doubled up ROMs. You know, this might be these two, this might be these two, that type of thing. This is a 4K ROM, whereas the 2716 is a 2K, so it's twice the size. Yeah, so I got that all done. I got the hack cleaned off the board. And these sockets I don't need to replace. These are not the traditional junk Atari sockets. These are decent dual wipe sockets, so I'm not messing with replacing these. Those are not bad sockets. So it's nice whenever I see these sockets on boards. It means I generally don't have to replace them. So that's nice. Okay, we're gonna hook back up and continue our testing. We were at this guy right here that we can now test. We can get at it now that the hack's off of it. And if I remember correctly, pins 1, 2, and 3 were all pulsing, but there was no outputs on it. So I think what I'm going to go ahead and do is I'll hook up, we'll probe it again with the logic probe, and then if I have to, I'll hook the analyzer up to it, and we'll look at what is going on inside this chip. I was just thinking about this, how we redid this ROM with these 4K ROMs instead of the 2K ROMs, and why you have to restrap the board. And I figured, maybe I'll try a little explanation of why is that. What exactly does it mean? How does ROM work, basically? Okay, let's start with a 2716. Okay, which is addressed by 11 pins. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's actually 10 address bits. I'm sorry. 2716 has 10 address pins. Okay, so its range is 0 to all of these being 1. So that is 7 F F. So that is the range of a 2716, 0 to 7 FF. You need 10 address bits to address a 2716. So generally what they will do is they'll take the 11th address bit and tie it to ground. Is generally what I see. It could be tied high. It's generally tied to ground. So okay, if you're going to restrap for a 2732, which uses one extra address bit, it uses 11 address bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It uses 12 actually. 0 to 11. 12 address pins. So its range is 0 to all of these being 1. So its range is F, F, F. So the range of a 2732 is 0 to F, F, F. Okay, this actually means this is a if you take all of these bits and you listed each address, you would get, because this basically 7FF in decimal is like 1023. No, it's 248. I didn't think that sounded right. 7FF, if you convert that to decimal, it's 2047. Well, you add 0 because 0 is actually an address. So it's 0 to 7FF. There's 248 spots. There's 1, 2, 3, 4, all the way down from 0 to 2047. That's 2,048 locations, each storing 8 bits. So you have 2048 locations, all storing 8 bits. Over here, it's just doubled. If you take FFF and you convert that to decimal, that comes out to 4095. Well, you got to add 0 because 0 is actually an address. So 0 to FFF is 4096 locations, because you got to include the 0. 0 is actually an address. So in this one, instead of 2048, there are 4096 locations, each storing 8 bits. So that's basically what that means. Most of you probably already know that, but who knows? Maybe someone find that interesting. And I did not touch on why you have to restrap, is because if you go to this guy, then you need address bit 11 to address this ROM. That's why there's strapping. You don't need it here, you do need it here. That's basically it. Okay, I just hooked up the board set with the new ROM configuration and all, and immediately I'm already getting something different. I'm getting static out of the speaker, and if I come over here and probe this guy, 1, 2, and 3, here's 1, 2, 3, Those are all moving. Okay. 4, this is output now. 5. 6 is now pulsing. So this guy, you remember, the output was always high. Now it's pulsing. This is at 32. We're still resetting, but we now have an interrupt. Interrupt is now active. It's pulsing now. It wasn't pulsing before. Okay. The non-maskable interrupt, I kind of want to look at the schematic because it's still held high, and it might be tied high, but we need to find that out for sure. But the interrupt is now pulsing, so we're just going to have to I want to look into the non-maskable interrupt. I want to look at that on the schematic, see if it's tied high. If it is, then I'm going to start looking at buffers. I'm going to start looking at make sure that our buffers are all good. So let's do that. I'm going to pull up the schematic, look for NMI, non-maskable interrupt. I'm going to look for that and make sure that that is moving. So let's do that. Okay, right now I'm looking at E2, just checking the buffers, and E2 looks really goofy. It is the ROM data buffer back to the CPU is what it is. And if I show you on E2, it's right here. It's this guy. And okay, that's good. That's almost non-existent. Okay. That is about non-existent. Really strange. And if I take my oscilloscope and look at, let's look at some of the data. That one looked okay. It sounded okay anyway. And this one right here is basically nothing. Yeah, that's okay. This one is also basically nothing. Yeah, that's okay. That's basically nothing. So it's either, what I think I want to do is I want to make a chart of what pin looks like junk, because this, you'll see, this is just randomly, it's just dumped onto the data bus. There's other things connected to the data bus. So let me scroll. Let's follow the data bus. Okay, well, there's the 245 right there. That really should not be affecting anything. And then that 245 there. So it's basically just the ROM data back to the CPU. It doesn't look like it's being interfered with anything else, because when the CPU is reading data from there, these will be disabled to allow it to go back to the CPU instead of going back out onto the data bus, the buffered data bus. So I'm going to replace E2 because I believe it's a problem. But it is totally possible that these two guys right here, that one of these is goofing up that data line, the data bus. It's absolutely possible. I'm going to start with E2. I think what I'm going to do is I want to probe these guys with my logic probe. But chances are one side's going to sound like crap and one side should sound okay. Garbage in, garbage out. So this is the problem with having multiple stuff attached to one bus. We got 3 chips attached to the bus here. This one could be goofing it up. That one could be goofing it up. It could be E2. So I'm going to start with E2, but I might end up replacing all 3 of them until I find the one that's actually dragging the lines. So I'm going to start with E2. Well, guys, guess what I did? Remember in the last video I remotely located this guy? Well, I shorted it. I shorted the power rails again and took it out. But what I did, I mean, it was nice to be able to just take it off of here, but I went a step further and I cut and I put a connector in. So now I have a quick, easy disconnect connector for it. A nice, easy fix. And yeah, it opened this thing up. I'm going through these things at an alarming rate. What happened was I had my scope probe by the board, and this, I have to come up with something different than this. That touched a 5-volt rail and immediately took this guy out. It acts as a fuse, basically. Opens it up. So I got a new one on there. I got a new quick disconnect. Freaking annoying. But I'm going to put that back, hook it back up, and continue. Guess what's never going to happen again? I got 2 alligator clips together and heat shrunk together. Okay, we're back in business. I got my new fix here. That's not going to short anything out, so let's get back to testing this thing. What I wanted to start showing you is logic probes can be deceiving. Like if you're probing this guy right here with a logic probe and it sounds great on this side, it is resetting, so it's going to be rhythmic, but that's good all the way down. And then you come over here and you're like, wow, that's kind of intermittent and kind of weird sounding. Well, now it's okay. But before, it was just weird sounding. All of the lines were like this. Okay, I don't like that noise. I'm going to unplug it and plug it back in. I shorted 2 lines together on the data buffer, and it just started making a weird noise in the speaker. So let's do that. Let's reset it, restart it. Anyway, this, maybe it'll do it now. See that? See how it's kind of weird? If you see that and you say, well, that don't sound like this. This is the one side, and then its output is this. You have to remember this is a tri-state buffer, and if you probe and you look at the actual signal, let me get on it good. You'll see it's tri-stated most of the time. Most of the time it's floating. But every now and again it will allow data through. These things, if they're not enabled, they'll float. The outputs will float. So, yeah. Anyway, this one was the one we were looking at that has just got some garbage signals on it. If I can find them. There we go. There's one of the garbage signals. And some of them look fine. That one's garbage. A point being, I guess, was this 245 here looks fine. I haven't looked at this other one here yet. We're going to go ahead and replace this 244 because that thing just does not look good. I should look at all of the address signals too. Let's do that right now. Let's start with, and I'm not going from point 1 over to point B like the input to the output. I'm just probing all of them. This is the enable. It's always enabled. That looks good. That looks good. That's good. That's good. That's actually a clock. That's good. That's good. That's good. And that's good. Other side. Pin 2. That's good. That's good. That's good. Okay. On down the line, that's fine. That looks good. That's good. And that looks good. Next, the next address buffer. This is the enable, which it is always enabled. And we just go one at a time down these lines and make sure they look good. And so far, these look really good. Okay, other side. All right, that's it. So we have 0 addressing issues on this board. We have a data problem from the ROM is what we have. So let me go ahead and, like I was saying, we have my phone just cut out. I do my videos on my phone and it just cut out on me. But like I was saying, we have a data problem from the ROM back to the CPU is the main issue that we have right now. And we are still resetting. So let's go ahead and replace the 244. Okay, I removed the 244 ROM data buffer from the board and it tested absolutely fine. There's only 3 other components that are tied to that data bus. The CPU and these 2 245s at H2 and F2. That's the only thing left there to corrupt that line. Now what could happen is the enables could fail and allow data, basically just open these things up. That could corrupt the data, or these could be bad. So we got some digging to do. I think first thing I'm going to do is I'm going to check and probe all of the direction and enable lines and make sure that they look good, nothing stuck, something like that. So let's go ahead and do that. Okie dokie, I'm hooked back up here. I just socketed this and put that chip back in. The 244 tested fine, so it's back in the board. I just was spending some time going over control signals for these buffers. And this is the enable, and this is only enabled. This is just an enable. It's a 244. 245s have an enable and a direction. This is the enable. You can see it's moving. This is the direction pin. It's moving. This one here's the enable. And it is not being enabled. This is the direction. Direction is moving. Enable is not. And then there's another 245 right here, and that is the vector generator data buffer. It's the vector generator RAM. It's all of these guys. Yeah, it's all of these 8 RAMs right here are buffered by this. And here is its enable is always high, stuck high. And the direction signal is working. I'm going back down to this guy right here. This is H2, and I think this is the one that sends data to the math box. This is the one that's connected to this here and sends data out to the math box when it's enabled, and it should be enabling more than that. Let's I'm gonna reset it. Yeah, it's not doing diddly squat. So the enable for H2 and H3, the enables are nowhere to be found. H2 and H3 are not being enabled ever. And here's reset. Reset goes high, goes low. It's resetting. No enables on H2 and H3. Well, that's definitely something to look at. So let's look at the schematic and find out where the enable for these two guys is coming from. Those aren't being enabled at all. Let's do that. Okay, I restarted this thing, and H2 I am now getting hammering the enable, and that's enabled by the IO signal, input output. And that makes sense because input output is on this board. So it's the input and output data. That's the enable. This thing is stuck high. This is buffer enable signal is supposed to be enabling this, and it looks like it's going now and again. But I don't think that's enough. This thing should be There's something wrong here. I mean, yeah, see it shoots down every now and again like that. But this should be really busy. I mean, this is the CPU talking to the vector generator RAM back and forth. This should be busy. It should be a lot busier than this. So that comes off of, and I'm not on it right now, but I know it comes off of K2, which is this guy. It's a MUX K2. And I believe it's pin 7. Yeah, it's pin 7, which is this signal, I believe, is tied high, and this. It's selecting between this and this. And the select on a MUX, this MUX, I believe, is pin 1, I think. Maybe it's 15. No. I don't know. I have to look at the schematic because I can't remember what the pins are on this chip. So let's pull the schematic up and find K2 and probe it proper. All right, well, this is very interesting. Remember, we're probing the buffer enable signal is now busy. Now it's working all of a sudden. And we are no longer resetting. I was probing around on K2 and all of a sudden it started working. Let's try to reset and see if we get the same thing. Reset is high. Okay, I'm probing the data buffer now. Which that signal still looks like garbage. And now it's resetting again. And we're getting an enable pulse there. Okay. And we're resetting again. How weird is this? You know what I'm going to do? I am going to put this thing into test and see what it does. I'm going to hook up my scope to it and put it in test. Because it's acting pretty funny. See what happens. I don't know. Well, let's just do that. Let's hook up and throw it in test. Well, I found out why my 2732 ROMs did not work in the Tempest PCB. I was using the wrong chip. I was supposed to use 2532. Address 11 was the extra address bit in the schematic. Address 11 is on pin 18, 2532. Address or pin 18 on 2732 is enable. 21 is address 11. So I had the wrong chip in. That's why it wasn't working. So I'm not going to change it at this point. I've already got it flipped around to 2716s again, so yeah. Okay. I don't know. Maybe I will. Maybe I will go 25. I'll see how many I have. If I have 6 of them, I might do that. Maybe not. I don't know. I'll think about it. But that's why it didn't work. Well, guys, I did some messing around with this guy here. I was probing this with the analyzer, and it was working, but the address bus bits that enable it would never line up to allow this thing to send like the video memory, the vector memory enable. It just would not line up to send that pulse to enable the vector memory. And we know, I've went through all of the address busing in these buffers. We know it's not, this thing got unbuffered straight from the CPU address lines. So it's basically, it's a short from the address line to here. There's no, it's not going to be bad. They were there. Well, a previous repair that I did, I had a problem with the vector timer cutting out. And I seen some address decoding lines, and that was ROM to me. I immediately thought, okay, this is a ROM problem. I did the same thing here. This was a ROM problem. So I put all of these ROMs in the board, and here it is. The pots are a little goofy. The pots need to be adjusted, but I'm not really worrying about adjusting pots, to be honest. The owner of the board, when he gets it and puts it in the game, he can dial in the pots. It's all of the data's right. Everything's good. It's just the pots are a little goofy. So I kind of messed with them enough to get it to look okay. But yeah, this is another software issue. And I had to re-jump. I had to move the jumpers back to here. I don't know what else was involved. There's not enough documentation. I was going over the schematic, trying to figure out what else you needed to do to get that other set of ROMs to work. And I just couldn't find anything. Do I have to scratch these pads? You know, there's a couple pads here that can be scratched. I don't know. I couldn't find any documentation on it. So I just went back to these ROMs. There is a way to make that other ROM set work on this board, but I just couldn't find it in the schematic. So I just put these ROMs in the board, and it works. So yeah, it's just another software issue. Straight up. Yeah, so it's basically all there is to it. But it's running perfect. No problems at all. Like I said, it just needs to be adjusted. The pots just need to be worked a little bit to really dial it in. Which I'm not going to do that because I might make it even worse in his game with this little screen here. You know, so that'll be up to the owner to dial it in with the pots. So. But that's it. I mean, I'm going to continue to look in the schematic to see if I can find any kind of documentation or anything online, or if anybody knows about, do these pads need to be scratched for it to run the other set of ROMs? Is there anything else on here that needs to be done? I don't know. So, okay. Well, I'm going to sit here. I'm going to let this thing run for a couple of hours, or at least 3 hours. Let this main board burn for 3 hours. And if it all goes well, then we'll call this one good. And I'm going to try to scrounge up some more ROMs and burn another set of these, because I pulled these off of the guy sent me, the owner sent me 2 main boards, and I fixed the one and I burnt these ROMs for that board. Well, I pulled those ROMs off of that board and put on this board to get this one working. So I'm going to have to scrounge up some more 2716s and burn a set for this. Oh, all right. Software problems, just keep that in mind. If you have problems with these boards, a lot of times it's software, especially if you got that stupid ROM hack on here. All right, thanks for watching, guys. I think this will be the last Tempest for a while, so we'll be getting into some other stuff coming up. Thanks a lot, and we'll see you.